We're going to do one more problem, this time using cyclohexyl halide. So to illustrate the fact that we need to have what are the products, predicted products, when we have a specific compound and we need to have the anti-periplanar configuration. So let's say that I have this compound, and this will be 1-chloro 2-methyl cyclohexane, but it's also cis. I forgot to write the chloro. So 1-chloro 2-methyl cyclohexane, cis. And I'm going to do also the products for the, in the case where we have the trans stereoisomer. Now, here notice that at this carbon here, we can draw this as in the chair conformation, because I need to have the leaving group opposite to the beta hydrogen. Notice this is alpha, your beta position, here you have one, and here you have another. But because I need to have that, the reactive conformation needs to have a leaving group at an axial position. If I do that, then to be cis, now the methyl group needs to be here. This is the same compound. Now, to do the mechanism, remember that here we have one hydrogen, we have two actually, but and here you have another. These are the beta positions that I mark. This is one of that, right? Here you have two, these are the two. This actually is the one that is anti-periplanar, so opposite, but you have another anti-periplanar. So doing that, let's draw the products. So say that you have a base here, then base is going to get this hydrogen, beta hydrogen. You're going to make a double bond again, concerted process, right? This is a parting. So my product here will be, I need to make a double bond here in this middle. And that is equivalent to the following. I will have a double bond here, and then in the next carbon, I'm going to have the metal. All right, and it's up. But what if the base attacks on the other hydrogen? That's another option that we have, another possible products. So every time that you're looking at how many products, you need to identify first your alpha carbon, then the beta position, and see if there are hydrogens. Next, they also need to be able to adopt a conformation such as in which the hydrogen is anti-periplanar to the leaving group. So check those three things. Where's the alpha carbon? Where is the beta hydrogen? And do we have beta hydrogens that can be anti-periplanar to the leaving group? And then draw your product. The other hydrogen that is anti to the leaving group is this one. So to the other side, this is this. And attacking that, you will make a double bond here. And now this is that. And not easy to draw, but I'm going to draw the metal here. That is equivalent to having now this. Now you're making a double bond here. Notice that you have now two products. Here you have a di-substituted alkane. Here you have two substituents on this carbon. Here you have only one. So that's tri. So the major product should be this one. Okay. We can also see the products right here. Here you have, if the metal is on a wedge, the hydrogen is on a dash, and you see that is opposite to the chlorine. At the other carbon, then you will have two hydrogens, and here you will have one on the dash, that is opposite to this, and one on the wedge. So yes, you can have the two products that we predicted, this one and this one. Now, let's see what happens if we now change the substrate, which is what we have in the drawing below. Here, to do it faster, we can locate the hydrogens, the beta hydrogen again, that's alpha, beta position, beta. Here you have two, and Let's see, we have hydrogen. Let's do, I'm gonna put the beta here. Beta. So what we see here is that in looking at that, these two, the beta hydrogen and the chlorine, they're not anti. They are seen pointing to the same side. So we cannot do an elimination here, but on this side we can. So this actually can only give you one product. So now, again, this is not in the appropriate conformation, it's not opposite, not anti-periplanar. This one is, and I'm gonna make another drawing of that. So notice the chlorine is down here, so I'm gonna put it on axial position. Remember that you want to put the leaving group on axial, always. Here it was up, so up here, now it's down. You want to put it so that you can have the anti-periplanar conformation. So if the chlorine is here, now the metal is up here. And so we see that if this is metal, these two are seen pointing to the same side. However, here you have hydrogen and hydrogen, and this one is opposite. So these two are anti. So actually, the trans can only give you one product, and it's going to be eliminating over here. Or in you can draw it in the chair form. We will do, so eliminating here. That's your double bond. A metal, and that you can draw as like that. So notice 1, 2, 1, 2, 1 carbon away, that, and that is the product that you can form eliminating over to the side. And remember, you cannot do so because these two are seen and they need to be anti. These two are opposite, this and that. These two are anti-periplanar. That's why we have only one product with the trans 1-chloro, 2-methyl cyclohexane, and we have two products when we have the cis 1-chloro, 2-methyl cyclohexane.